Imagine opening your eyes in a place where the sky ripples like heated metal and the ground trembles as if the entire world were breathing beneath your feet, a place so far from Earth that even imagination struggles to understand its shape. Beyond the soft blue glow of our familiar world, the universe stretches into a darkness, filled with impossible worlds, each one more extreme than the last, each one challenging the very foundations of physics, chemistry, and the laws that science once believed to be unbreakable. These planets do not simply orbit their distant stars. They distort them, bend them, reflect them, consume them, and sometimes even survive them in ways that seem to rewrite the rules of reality itself. As your mind drifts outward past the frozen shells of faraway moons and the lonely dust of interstellar space, you begin to sense the presence of these impossible worlds waiting silently in the dark. Each one holding stories carved by fire, pressure, gravity, and strange forces that no model fully explains. This journey will take you through the heart of 5 planets that defy scientific understanding, and, as you move closer, the darkness around you begins to pulse with faint starlight, guiding you toward your first impossible world. The first planet appears like a violent storm frozen mid-breath, a world so hostile that no imagination could prepare you for its beauty or its brutality. This is HD 189,733b, a gas giant orbiting its star with such proximity that its dayside burns at temperatures capable of vaporizing minerals. The heat is so intense that rocks are lifted into the atmosphere as vapor, drifting into clouds made of tiny shards of silicate glass. Winds travel at thousands of miles per hour, pushing these particles sideways across the planet in a horizontal rain of razor-sharp crystals. Imagine standing in a storm where every drop is a blade, where the air itself tears the landscape apart, where nothing solid could ever survive. The contrast between the blazing dayside and the cooler nightside creates a violent circulation pattern that should, by all predictions, rip the planet's atmosphere into shreds. But somehow, impossibly, it remains intact. Scientists understand the heat. They understand the winds. They understand the chemistry of vaporized minerals, yet no one fully understands the delicate equilibrium keeping this monster of fire and glass from evaporating into space. HD 189,733b stands as a cosmic contradiction, a world that should not remain whole, but does, spinning endlessly in a glass-filled hurricane that challenges the limits of atmospheric physics. Far beyond this storming giant lies a planet so dark that even the deepest shadow on Earth would seem bright in comparison. Tres to b reflects less than 1% of the light that touches it, making it darker than coal, darker than volcanic ash, darker even than hardened tar beneath a moonless sky. When astronomers first measured its reflectivity, the data seemed impossible. No natural material known to science absorbs light with such extreme efficiency. Some theories proposed atmospheres rich in vaporized metals. Others suggest complex interactions involving titanium oxide or chemical compounds that trap photons in unpredictable ways. And yet every hypothesis opens new questions. What chemical mixture could create a darkness so absolute? What atmospheric structure could swallow starlight so completely that the planet becomes almost invisible? Imagine a world where noon feels like twilight, where colors cannot exist, where nothing reflects or glows or shines. Tres to b is like a cosmic void disguised as a planet, orbiting its star with a stealth that defies understanding. It should not be able to maintain such darkness, and yet it does, mocking the simplicity of every textbook explanation of reflectivity and atmospheric physics. Deeper into the galaxy, you encounter a world that seems carved from fantasy, but forged in fire. This is 55 Cancri, a planet believed to contain enormous amounts of carbon under such pressure that its interior may contain layers of solid diamond. But the reality is far more violent than its nickname suggests. The surface reaches temperatures capable of melting iron, creating rivers of molten rock and plains that glow with blinding radiance. The heat distribution across the planet defies model after model. Some regions flare unpredictably, while others cool when they should not, creating a pattern that feels more like a heartbeat than a geological process. Lava lakes form, collapse, reform, and shift with mysterious rhythm. Imagine a world where the mantle churns like a boiling ocean of fire beneath a crust struggling to remain whole. The possibility of diamond within such chaos only deepens the mystery. How can such an unstable world maintain crystalline structures under impossible conditions? 55 Cancri behaves like a living furnace, pulsing with energy and pressure that push against every scientific explanation. It is a world that shines in theory and burns in truth, a paradox of beauty and destruction. Your journey continues to a world so swollen and ethereal that it challenges the concept of density itself. WASP 17b is almost twice the size of Jupiter, yet has such low density that it would float in water if scaled to a planetary ocean. It is an enormous balloon of hydrogen and helium stretched outward by the relentless radiation of its host star. But what confuses scientists is not its size. It is its stability. The upper layers of its atmosphere should have been stripped away long ago by the intense heat, but the planet remains inflated like a cosmic lantern. Adding to this strangeness, WASP-17b orbits in a backwards direction relative to the rotation of its star, defying the angular momentum patterns that govern star system formation. Its shape is slightly distorted, stretched into an oblong form by gravitational interactions that should over time compress it. Yet it remains expanded and serene. Imagine watching an enormous, luminous cloud drifting through space, held together by a fragile balance that should not be possible. WASP-17b is a planet that behaves as if gravity were a suggestion rather than a law. And then comes the most haunting anomaly of all. A world that should not exist under any circumstances known to astrophysics. Kepler-17b orbits so close to its star that one complete year lasts only hours, racing in a blistering loop that skims the stellar surface. Temperatures on this world reach extremes beyond any planetary environment ever measured. But the true impossibility is not its heat. It is its survival. The star it orbits once expanded into a red giant, a phase that should have engulfed and destroyed any nearby planets. Everything close to the star should have vaporized into atoms. Yet Kepler-17b remains orbiting undeterred, as though it endured a cosmic disaster that erased entire worlds, while sparing this one by an unknown miracle of physics. No known mechanism allows a planet to remain intact through the red giant phase. No formation path explains how it arrived in its current orbit afterwards. Its existence is like the last page of a book that should have burned with the rest of the chapters but somehow survived, carrying a message from a past that should have been erased. As you drift away from these impossible worlds, the darkness of space feels deeper, almost conscious, as if it were listening. These planets are reminders that the universe is not a place of simple rules. It is a place of exceptions, contradictions, and mysteries that stretch beyond the reach of equations. Each impossible world is a question carved into the void, urging humanity to search, to learn, to wonder, and to accept that the cosmos is far stranger than our current knowledge allows. The more we discover, the more we realize how little we understand. And these planets stand as monuments to that vast, humbling truth. They are not just objects in space. They are cosmic riddles waiting to be solved, one impossible orbit at a time.